Okay, so let's talk about velocity time graph now. As you can see in the first graph, the line is straight and horizontal. So what does it tell? It is telling you that the velocity is constant, right? The velocity is not changing at all. What about the slope? The horizontal line is telling you that the slope is 0. If the slope is 0, that means acceleration is 0, and you don't need to know about the force of direction of force, because if acceleration is 0, then that means there is no force at all, right? And if you can see in the second graph, the line is increasing uniformly like this. As you can see, at 1 the velocity, the time was 1 second. Like at 1 second the velocity was 1 meter, and at 2 the velocity was 2, at 3 it was 3. So the velocity is increasing in a uniform manner. So that's why you can say that the velocity is increasing uniformly. So the velocity is uniform and it is increasing. What about the slope? The slope is positive, right? The slope is telling you that it is positive. Acceleration is also positive, but the slope is constant, and the acceleration is also constant. What about the direction of force? Whenever the acceleration is positive, then you automatically know that the force is in the direction of motion. For example, if a car like this is moving forward, right, and you use the force in the motion of the car, then the acceleration would be in the same direction. That in this situation, the acceleration would be positive and the force would be in the direction of motion. But for example, if the force is in the opposite direction of the motion, then the acceleration would be negative, and that is the next situation that we will talk about. So but in this particular situation, as you can see, that acceleration is positive. So this is telling you that force is in the direction of motion. So graph can tell you a lot about the motion of an object. Like this single line is telling you what is the velocity, what is the slope or acceleration, what is the direction of force from one single line, right? Let's draw another graph like this. What does this graph is telling you? First of all, the line is not changing at all. You know, if the line was like this or this, then the graph would have been non-uniform, but the line is really straight, so that means the velocity is uniform, right? But the velocity is decreasing. Simple, right? Not hard at all. What about the slope? As you can see, the slope is negative, right? And it is constant. What about acceleration? The slope is acceleration, so it is negative and constant. And if the acceleration is negative, then what does it tell you? That the force is in the opposite direction of the motion, or you can say that it is retarding force, right? The process that is occurring here is retardation. So if you ever wonder what is the graph for retardation, so it is right in front of you. Okay, so let's make another graph like this. What does this graph tell you? First of all, at one glance you know that the graph is non-uniform, right? And what is happening? Is it increasing or is it decreasing? If you see the y here, the y is increasing, right? So that means the velocity is increasing. What about the slope? The slope is positive, and is it increasing or decreasing? As you can see, it is toward 90 degree. That means it is increasing. Same for the acceleration, because acceleration is actually the slope, right? If you're getting confused about slope and acceleration, actually they are the same thing here. Like the slope is the acceleration. For the slope of velocity time graph is acceleration, but I wrote them differently so that you know that like slope is acceleration and acceleration is slope. What about the force? If the acceleration is positive, then that means the force is in the direction of motion, right? What about this graph? As you can see, the graph is non-uniform. Simple. You can see at a glance that it is non-uniform, and whether it is increasing or decreasing, you have to tell me first. This is one of the most trickiest question, because so I will write it down in a blue marker. So first of all, you have to note what is the slope. The slope is positive and acceleration is also positive, and the direction would be in the direction of motion, right? The force would be in the direction of motion. So this graph is really tricky. The reason is that if you see about the slope, what we talked about, increasing or decreasing of the slope, we talked that if the curve is towards 90 degree, it is increasing, and if it is away from the 90 degree, it is decreasing. As you can see, the curve is going away from 90 degree. So what does it mean? That the slope is decreasing, right? And acceleration is also decreasing, but not for the velocity. The velocity is actually increasing. Like, what the hell, sir, what are you talking about? The answer is simple. You can see the y component here. The y component has been increasing for the velocity, so the velocity as a whole is increasing. But for the slope, as you can see, we have to see the slope at a specific point, not the whole graph here. Like, if you see the whole graph, it has moved from 0 to 15, right? But when we are talking about slope, we will talk about a specific point at here, and at that specific point the slope is decreasing. So that's why I told you before, the shortcut formula in the books we talked about was that if the curve is toward 90 degree and away from 90 degree, it will tell you about slope. It will not tell you about what is happening in the total motion. For example, you started your bike and you went from one place to another place, and during the whole motion you traveled 5 kilometers. So obviously you covered 5 kilometers, but in that 5 kilometers, at the last kilometer, you slow down your speed, and slowly your speed becomes 100, 80, 70, 60, 50, 40, 30, and then eventually it became 0. Then during the last kilometer, your slope of motion was decreasing, but that doesn't mean you was not covering any motion at all. The slope was obviously decreasing, but the motion was still going on. So that's how you can see the difference between velocity and the slope. If the velocity is increasing, that doesn't mean the slope is also increasing. The slope and velocity are different things. So that was the thing that I had to point it out in that particular question. So these were all the graphs that you had to study for velocity time graph. Then you have the graphs for projectile motion. We will do them later in our lecture, because we have to study the projectile motion first to make the graphs for projectile motion. So the next topic is about free fall and terminal velocity. So first is free fall. Free fall means, for example, if you have a ball like this and you release the ball in the air, the ball will start moving downward due to the gravity. And all the objects in free fall have constant acceleration. The acceleration is always constant. Why is that? Because acceleration at that time is gravitational acceleration, and it is 9.81 meter per second, and it is always constant. So that's why during free fall you can say the acceleration is always constant. What about the net force? The net force is actually not zero. You have to memorize that if acceleration is constant, then net force is never zero. And what about the velocity? The velocity is actually changing. Why is that the velocity changes? As you can see, at initial point the velocity was 0, and then the velocity is slowly started increasing, and eventually it will reach the terminal velocity. So during free fall, from start to terminal velocity, the velocity actually changes until it reaches the terminal velocity. So let's talk about what is terminal velocity. As we talked before, if you release a ball, like if you just released, the net force that is acting on it is only the weight of the ball. There is no other force that acts on it, and the acceleration is 9.8. Simple. The next thing is that when it come to like this point, like in the middle, it will start falling faster, the velocity will increase, and at that point the weight will be greater than the drag force. So what is drag force? Drag force is any force that opposes the motion of an object that is going through a fluid. For example, if you throw a ball in a water, then what will happen? The water will slow down the motion of the ball. That is the drag force. Drag force will stop the ball from moving. So what happens here is that whenever a ball falls from air and it starts going downward, the drag force of air stops the motion of the ball. You have to know that air and water, both of these are fluids, so they both act as a drag force against the motion of an object. For example, if you are moving in really high amount of air, for example the air is really hard, then you have difficulty walking in strong air, right? And similarly, you have really high difficulty in walking in water. The reason is because of drag force. Whenever the ball starts increasing the speed, the velocity starts increasing, then the weight starts having drag force. But still at this point the drag force is not that high, the weight is still higher than the drag force, but eventually it will reach a point in when the velocity becomes maximum, like the speed or the velocity cannot increase at all at this point. So that point at which the velocity cannot increase any further is called the terminal velocity. So now you know what is terminal velocity. Terminal velocity is the velocity that during free fall the object gains maximum amount of velocity, that is actually terminal velocity. And during the terminal velocity the weight becomes equal to the drag force. That is the point that you have to memorize, that is the point that you have to know. IMAT exam is going to test this point from many different angles. So you have to know that during the terminal velocity the weight is always equal to the drag force. You can write it down it as F equals to mg. F equals to mg means that the drag force is equals to the weight of the object. So this was from the side of terminal velocity. So these are the really important points. You have to like be really careful while solving these kind of questions. Let's talk about equation of motions. Like these equations of motions are the equations that will be mostly used in IMAT exam. Like these are the equations that are so important, like they are asked every single year. Like there is a numerical or question from these equations maybe like every year. I haven't seen a question that is not using these equations. Like these are equations that are the most important. So first of all, before jumping into the equations, we have to know what is the prerequisites for these equations. You have to know that these equations are applicable to a certain prerequisites, and the prerequisites are, the first thing you have to know that is the speed of the object that you are studying using these equations should have speed really smaller than the speed of light. For example, these equations are not applicable to the objects that are traveling really fast or closer to the speed of light. So the speed should be smaller, really smaller than the speed of light. Like these equations are not applicable to speed of light or anything that is close to speed of light. The speed of light, as you can see, is 3 cross 10 raised to power 18 meter per second. The second thing is that these equations are only applicable in inertial frame of reference. What is inertial frame of reference? We will talk about it in just a second. The next thing is these are only applicable for uniform acceleration. If the acceleration is uniform, then these equations are applicable. If the acceleration is not uniform, then these equations will not be applicable at all. The next thing is about that they are applicable only on linear motion. They are not applicable to like rotational motion or or on simple harmonic motion? No, they are only applicable for linear motion. So let's talk about the equations. The first equation, as you can see, is that the symbol v is showing you the final velocity. You can also write it down as vf equals vi, that is the initial velocity, plus at. The first equation is actually independent of distance, so you can say that this equation is distance independent. What about the second equation? The second equation is saying f equals vit plus half at square. You can write it down as f equals vit plus half at square. What about the third equation? The third equation is vf square equals vi square plus 2as, or you can also write it down as 2as equals vf square minus vi square. So these are the equation of motions, and the last equation is about f equals 1/2 initial velocity plus final velocity multiplied by time. So these are the equations that uses distance, initial velocity, final velocity, acceleration and time. You can see that the third equation is independent of time, so it is time independent. And the second equation is missing final velocity, so it is vf independent. So these are equations. You don't have to know the derivation for these equations, how they came to and what are they doing here. You just have to memorize these equations because they are really important and you will be using these equations a lot. So the thing is that how we know what equation will be used in the numericals. So the first thing that you have to know is that, like, you should be knowing all the variables in the question. Let's solve a question right here. They are saying that a car accelerates from rest. So what does the rest means? That the initial velocity is 0. You can write it down is here, like initial velocity is 0. And what about final velocity? The final velocity is not given here. The next thing is about acceleration. The acceleration is 3 meter per second square. How I knew that it is acceleration? From the unit. The unit is telling me that it is acceleration. The next thing is about time. The time is 8 seconds. So the things that you have to find is the final velocity and the distance traveled. So as you can see, you have been given initial velocity, acceleration and time. You need to find final velocity and distance. So first you have to find final velocity, right? So you have to see in which of these equations final velocity is present. Final velocity is present in first equation and third equation. And the thing is that what is missing here? The other thing that is missing here is distance. So you have to know that the third equation has distance, so we won't be using the third equation because we don't have the distance. We have acceleration, we have initial velocity, but we don't have distance. In the first equation we have initial velocity, we have acceleration, and we also have time. So now you know that you want to use the first equation. So the first equation we used the values. The initial velocity is 0, acceleration is 3, the time is 8 seconds. The answer for final velocity is 24 meter per second. So that's how you can find the answer. What about the distance travel? So let's take a look about equations that have distance. So you have two equations, that is second equation and the fourth equation, that is used to find the distance. So can you see which equation can be used to find the distance? If you take a look, you can use both of these equations. Like both of these equations can be used to find the distance. What about the third equation? The third equation can also be used. The reason is that because now you have all the variables instead of distance. Like other than distance you have all the variables, so distance can be found from any of these equations. So the equation that we used is second because I thought that maybe second might be easier. You can use any of these equations, you will get the same answer. I thought that maybe using second equation was much easier, so I used the second one. So the initial velocity was 0, time was 8, so that's why the whole equation was terminated. What about acceleration? Acceleration is 3, the time is 8. We have 8 squared multiplied by 3 divided by 2, you will get 96 meter. So that's how you can use equation of motions in your IMAT preparation. So you have to memorize these equations by heart. They are really important. And we talked about frame of reference. Let's talk about what is inertial frame of reference and what is non-inertial frame of reference. First of all, inertial frame of reference. Inertial frame of reference means that there is no acceleration. Inertial frame of reference means the acceleration is 0. When does the acceleration is 0? There are only two conditions. Either it could be at rest or the velocity can be constant. In both of these conditions, the acceleration is 0. What about non-inertial frame of reference? Non-inertial frame of reference means that the acceleration is not 0, like the body is accelerating, or you can say rotating. That means the acceleration is not 0 and the torque is also not 0. You can say rotating, or you can say that torque is not equal to 0. So this is a non-inertial frame of reference. So what is the example of non-inertial frame of reference? In non-inertial frame of reference, you feel pseudo forces. What are pseudo forces? Pseudo forces are the forces. For these forces, we can't see the origin. Like the origin is missing. We don't know where they originate from. So these are called pseudo forces. Like for example, when you are like in a car and you suddenly feel a pull, right? And that pull is because of the brakes. When you suddenly apply a brake of your car or your bike, then you suddenly feel a pull that moves you forward, and that pull is actually a pseudo force because you don't know where it originated from. So that is an example of a pseudo force. So pseudo forces are example of non-inertial frame of reference. And for inertial frame of reference, you have equation of motions. So equation of motion is only applicable when the acceleration is in non-inertial frame of reference. Like either the acceleration is constant or the acceleration is 0. Other than these conditions, these equations are not applicable. If the acceleration is constantly changing, then these equations will not be applicable. So the acceleration should be either constant or it should be 0, or these equations will not be applicable. So these equations are really specific, and now you know when these equations are to be applied. When the speed is really smaller than the speed of light, it is applicable. When the acceleration is uniform, it is constant, or the acceleration is 0. They are only applicable for linear motion. They are not applicable for the motion that is rotating or during torque or rotating motion. So these are the equations that are used. You can also change these equations when the object is moving in a vertical direction. For example, if you throw an object from above, or you throw an object above into the sky, so the equations will turn like this. You will write distance in the place of height. You will write height in the place of distance. You will write it down ut plus half. In the place of a, you will write down g, because in vertical direction the acceleration is gravitational acceleration, so you will write down g instead of a. And that's how you can also write down vf square equals vi square plus 2gh. So that's how you can use these equations in vertical motion too. These questions might seem a bit simple or too basic for you right now, but these are the questions that IMAT has been asking in these days. If you think that these questions are really basic, then do a lot of practice, because practice will make you perfect. Because IMAT won't be asking what is first equation, what is second equation. They will be giving you numericals, they will give you problems, we will be solving these kind of problems a lot, and after solving these problems you will know when to use which equation, how to use which equation, and why these equations are so important. Because even these questions might seem simple, look really simple to you, but many students still get these questions wrong. Last year, like, I did a poll and about 60% of the students left this question in IMAT exam. Right, like, it might seem really simple to you, but in IMAT these questions are not so simple. They are going to be asking you equations of motion and their applications in not a really straightforward way. So our last topic is about projectile motion. So projectile motion is simply the motion in two-dimensional motion. What does two-dimensional motion means? Like, the object is not only moving forward, or it is not moving only above or downward, it is moving two motions at the same time. If you can see at this place, it is moving upward and forward at the same time. So that's why projectile is a two-dimensional motion. The next thing is that you have to know that in projectile motion there are some prerequisites. What are those prerequisites? The first prerequisite is that the force for horizontal direction is 0. The second prerequisite is that acceleration for horizontal direction is 0. And the third prerequisite is that the velocity for horizontal direction is constant. Why is that the horizontal direction has these things constant? Let's get back to the diagram. As you can see, the only force that is on this motion is the force of gravity. So where does the gravity pulls the object? It pulls the object downward, right? What is the force that is happening in the horizontal direction? There is no force at all, right? The only force that is happening is the weight of the object that is pulling the object downward. So that's why in the horizontal direction there is no force. That's why the force is 0. If the force is 0, then automatically the acceleration is 0, because you know the formula F equals to ma. If in any way force is 0, then the acceleration becomes 0 automatically. So that is the reason that in the horizontal direction the force is 0 and the acceleration is also 0. What about the velocity? In the x direction, if we write it down here, if there is no force, if there is no acceleration, then the velocity will not change at all, right? The velocity will remain constant. That's why in x direction the velocity will remain same at every single point. It will not change at all. Let me draw velocity at every single point like this. As you can see, the velocity is not changing at all. It is same at every single point. What about the y direction? Like, if we talk about Vy in the vertical direction, whenever the object, for example, it is a ball, right? Let me draw a ball. You kick the ball and the ball went like this, and from point A it reached point B. And in the whole motion, first of all, the ball started going upward and forward, and in the upward and forward motion, and when the ball was going up, the velocity kept becoming slow and slow and slow. Eventually it became minimum. The velocity became minimum at the maximum height. The reason was because the gravity was pulling the ball downward. So in y direction the only force is the gravity. So the gravity was pulling the ball downward. So that's why when the ball was going upward and forward, the velocity kept decreasing and decreasing, and eventually it became 0 at the maximum height. And when the ball started coming down, the velocity started increasing. As you can see, when the ball started going down, the velocity started increasing, and it kept increasing and increasing and increasing. So that's why the y component of velocity changes while the x component of the velocity does not change at all, because in the x component there is no force acting, the acceleration is 0, while in the y component the force is the force of gravity, and because of the force of gravity the velocity keeps changing. So that was about the basics of the projectile motion. So let's talk about the types of projectile. Like there are two types of projectile. The first is horizontal projectile and the other is, you can say, the vertical or oblique projectile. The first is horizontal, that is like this, and there is a oblique projectile that is like this. You can say it is vertical projectile, or you can also call it oblique projectile. It is horizontal projectile. So these are the two types of projectiles. As you can see, the formulas are written here. The ax equals to 0 and the ay in the vertical direction, the acceleration is the acceleration of gravity. If we talk about velocity, the formula for velocity is vfx equals vi cos of theta. Memorize this formula. This formula is really important. You have to be using this kind of formulas in IMAT exam. The formula for vertical component is vfy equals vi sine of theta minus gt. So this is the formula if you want to find final velocity in vertical direction. So final velocity in horizontal direction has this formula, and velocity in the vertical component has this formula. So this formula can be used if you want to find final velocity in projectile motion. These kind of questions are not really common in IMAT. Projectile motion is not to be going into really depth or really high detail, so we are going to be remaining on the surface level. We will discuss things that are not really hard and easy to memorize. If you want to find the formula for distance, if you can see, what is the formula for distance? As you can see, s equals to vt. What is the formula for distance? Distance equals to s equals to vt. This formula came from velocity equals to distance over time, and I write it down as distance equal to speed multiplied by time. So when you say that the horizontal distance is x, let's say the distance here is x, right? And the velocity, as you can see, the velocity here is vi cos of theta. When I put it here, you will get vi cos of theta, and the time is same. You will get the formula for horizontal distance like this in a projectile, right? And for y component, the formula is y equals vi sine of theta, right, multiplied by t plus half gt square. This is the second equation of motion, and you can use it to find the distance for vertical motion. And if you are wondering about why we used second equation of motion in this formula and we used like s is equal to vt in the horizontal direction, the reason is simple. I will give you a hint, but you can figure it out on your own. I know you are really smart. As you can see, the formula for distance is s equals to vit plus half gt square. So this is second equation of motion, right? If you say that x can be either, distance could be horizontal distance or it could be vertical distance, right? If we have to find the vertical distance, can you tell me what is acceleration? You can say a is equals to x. What is ax? As you can see, ax equals to 0. So this whole equation becomes 0 and you will get the formula s is equal to vt. But if you want to find the vertical distance, then you will use this whole equation. You will put down the value of vi, that is vi sine of theta, and you will write down the value plus half gt square, same as it is. So now you know where both of these formulas came from. These came from the same single formula, s is equal to vit plus half at square, but the distance for both of these are different. The horizontal distance is different and the vertical distance is different. So that was all about if you had to find the horizontal and oblique distance in vertical direction and in horizontal direction. So memorize this formula, they are really important. Let's talk about some other important formulas. The first important formula that you have to know is about range. The range is the first important formula that you have to memorize. What does the range says? the formula for range is R equals Vi square sine 2 theta divided by G. So that was the formula for range. What about height? Height has the formula written as Vi square sine square theta divided by 2G. What about time? To find the time of projectile, the formula is 2Vi sine of theta divided by G. So these were all the formulas for range, for height, and for the time for the projectile motion. So what does all of these questions mean, and what does these formulas mean? Let's discuss all of these things in detail. The first thing is about the range. What is range? Range is the horizontal distance that a projectile covers. Like for example, if it is a projectile, then this is the distance that is covered by projectile. This is called as range. If we talk about height, what is height? Height is the vertical distance that is covered by projectile like this, and time is the total time that it took for the ball to go from point A to point B. The total time that it took is called time interval. So these are the formulas that you have to memorize: the formula for range, the formula for height, and the formula for time. You don't have to memorize the derivations where these formulas came from. You just have to memorize these equations directly. Just memorize these equations and you are good to go. Let's talk about some important points for projectile motion that might come in handy in your IMAT exam. The first important point that you need to know is that when does the projectile motion is maximum. If I draw the graph like this, and this is the projectile motion, let me ask you, at what angle the projectile could be maximum? This is projectile 1, this is projectile 2, and then I draw another projectile like this, another projectile like this. As you can see, the projectile that has the maximum range or the maximum distance covered is the red one. The red color has 45-degree angle. If we see that if the angle was increasing, for example, in the blue line, the angle increased a bit, maybe you can say to 50-degree, the range decreased. When you increase this to 60-degree, the range decreased further. But if you decrease the range, for example, from 45 to 30-degree, the range decreases anyways. So what does it mean? That at 45-degree, the range is maximum. If you go from 45 to 50, the range will decrease. If you go from 45 to 40, then the range will also decrease. That means range is maximum at 45-degree. If you go from to 50 or 40 or 30, the range will decrease. No matter if you go above or below 45-degree, the range is going to be decreasing. So that is like the hack that you need to know about range. Let me ask you another question. If we have 4 options, the first option is 70-degree and 90-degree. The B option is 60-degree and 20-degree. The Charlie option is 50-degree and 40-degree. The Delta option is 90-degree and 80-degree. If I ask you that at which of these angles have the same range, like if you talk about 70 and 90-degree, do they have same range? If you talk about 60 and 20, do they have same range? And if you talk about 40 and 50-degree, do they have same range? And if you talk about 90 and 80-degree, do they have same range? So that is the question that you have to ask yourself. So first of all, the answer is simple, that is C option. The answer is C. Why is that? Let me draw the diagram for you like this. this is 45-degree angle. First let's draw it, and if you increase the angle from 45 to 50, then the object will fall like this. Okay, so this is 50-degree, and if I decrease the angle 5-degree more, then the ball will fall like this. As you can see, the 40-degree and 50-degree angles are falling at the same time. Why is that? Because they have the same difference from 45-degree. If you increase 5-degree or if you decrease 5-degree from 45-degree, then both of them will fall at the same place. If you talk about 60-degree and 20-degree, 60-degree will place the ball a bit farther away. The 60-degree will fall like this, and 20-degree will fall like this. 20-degree and 60-degree will not have the same range. If you talk about 70-degree like this and 90-degree like this, they will not have the same range. Sorry about that. 90-degree will have a range like this. Okay, so the only range that is same is 50-degree and 40-degree. I think you understand what the concept here is. The concept is that the range is maximum at 45-degree. If you go above 45 or go below 45, the range is going to decrease no matter what. So this was the formula for range, and the maximum range is at 45-degree. If you go above or below 45-degree, the range is going to be decreasing no matter what you do. Let's talk about other examples. The other thing is that about the Earth. What does Earth have to do with the projectile motion? Actually, the Earth could be either flat or curved. What does it mean? For example, if you are taking a really small portion of Earth, for example, if you take 1 kilometer, then the 1 kilometer will seem straight to you, it might seem flat to you. But if you go up in the sky, in the space, you will see that the Earth is a bit curved. So if you take a really small part of Earth like this, then the projectile will be flat on Earth. But if you take a really big part of Earth, then the Earth will seem a bit curved for the projectile motion. I think you understood what I'm trying to say, that if you take a small portion of Earth, the Earth will seem a bit flat. If you take a large portion of Earth, then the Earth will feel a bit curved. So for both of these situations, the projectile would be different. For flat, the projectile would be parabolic. Okay, and for curved surface, the projectile would be called elliptical. So for the flat surface, this is parabolic, and for the curved surface, this is elliptical. So the parabolic path is when the Earth is flat, and the elliptical path is when the Earth is a curved surface. So this was all about the projectile motion. So these are all the shortcut formulas that you need to solve all the projectile motions. You memorize the most important part, that was about range for projectile. The range is maximum at 45-degree. You studied the formula to find horizontal and vertical distances in projectile. What is constant, what is zero? You know that the vertical components are changing while the horizontal components are constant. So this was all about projectile motion. In our next lecture, we will talk about dynamics. So the kinematics portion is over. So do the practice questions from this chapter as much as you can. The lecture is not enough to complete your preparation. The only thing that makes your physics preparation complete is the practice questions. Like if you are not practicing a lot amount of questions, then these formulas will fade away eventually. The formulas are useless if you are not practicing these formulas into your IMAT preparation. So use these formulas again and again in your preparation. I am telling you, like, you know which topics are important. Projectile motion is low yield topic, equation of motions are high yield topic, free fall and terminal velocity is high yield topic, graphs is a low yield topic, and velocity and these formulas that we discussed about sign convention and kinematics, all of these formulas are really high yield topics. I have been telling you guys again and again which are high yield, which are low yield, where to focus your energy on, and where to avoid these kind of questions. So this was all about kinematics portion. Now you know that we have covered everything that is about kinematics. We have not left anything. So if you have any question, you can write them down in the comment sections. We will discuss all these concepts, and if you have any problem, we can discuss it in our weekly live sessions. So that was all from my side. Take care. Bye bye.